Hello once again, Internet. I'm making this video because yesterday I talked with a student who was not actually in my pre-calculus class, but he was in Algebra 2 and had covered trigonometry already. And he told me he watched my video yesterday about trigonometry and that it was still confusing. And that's understandable because trigonometry is not super easy to understand at first. But once you get it, it makes sense. But basically what I want to do is try again to explain the trigonometric functions. So trig functions. Those being sine, cosine, tangent, etc. being cosecant, secant, and cotangent. Okay, so what we are trying to discover when we apply sine, cosine, tangent, etc. trigonometric functions, we are trying to find the coordinates of a point, okay? So the point is defined by the angle and the unit circle. So the unit circle, we have to remember, is a rectangular coordinate system. It's on a rectangular coordinate system. So it has an x-axis and a y-axis. So I'm going to go ahead and ruin this unit circle for the purpose of this. So you should feel very special. Okay, so the point at 45 degrees, it actually defines a triangle from the origin to here, and it's a right triangle. Okay, so we have the radius, which in a unit circle is 1. So the radius is 1. This is going to be really confusing because there's writing all over this already. That's okay though. We have also the height, which is y. Okay, it's our y coordinate. 1 is r. And then we also have its length on the bottom, its base, if you will, which is x, okay? So what do we have here then? We have a right triangle. This is a 45-degree, approximately, right triangle. We have r, y, and x. You know, another way we could write that is c, A, and B. Okay, now things are starting to look a little different. You can use this as the Pythagorean theorem. Okay, you can use it like the Pythagorean theorem. So if you have your x coordinate and your y coordinate, you can use those to find your r coordinate, which is actually something we'll be finding out later. But in this case, r is always 1. So at 45 degrees then, the x coordinate is square root of 2 over 2, and the y coordinate is also square root of 2 over 2. They're the same. So the length of y is square root of 2 over 2. The length of x is square root of 2. And the length of the radius is 1. That's always the same in a unit circle specifically. So we want to say then sine of pi over 4 or 45 degrees, then that is just the y coordinate. Okay, so it's square root of 2 over 2. And that is also known as the length of y. There, length of side y. It's the length of this side, which is just the distance up, which is the y coordinate. Cosine pi over 4 is the x coordinate, which is square root of 2 over 2. Okay, and tangent is y over x. So y over x the same way we can, what am I writing? Pi. We can write 2 over square root of 2, square root of 2 divided by 2 over square root of 2 divided by 2. That can be written as a multiplication problem equals this, where you put the one on the bottom here, you just flip it upside down and multiply it. That cancels, cross-canceling, and we get 1. Okay, so tangent equals 1. Tangent of pi over 4 equals 1. Oh, that works out nicely, doesn't it? And continuing, I'm going to do this over here now. Cosecant is the inverse of which one? Sine. Cosecant is the inverse of sine. So cosecant equals 2 over square root of 2 then, if you just take this sine and flip it upside down. That's not a good enough answer though. We don't want a square root on the bottom. So we multiply it by square root of 2 over square root of 2, which is 1. Square root of 2 divided by square root of 2 is 1. So we multiply this, so you go across. Square root of 2 times square root of 2 is 2. And then 2 times square root of 2 is 2 times square root of 2. And then you have these 2's here. They can cancel. So cosecant then is square root of 2. Secant of pi over 4 is also 2 over square root of 2 because it's the upside down of cosine. And we've done the math already, so let's just say it. It's square root of 2. And cotangent is the inverse of tangent. So what's 1 over 1 flip side upside down? That's just 1. So it's 1. Those are all 6 trigonometric functions of pi over 4, or 45 degrees. Same thing. Okay. So now let's take a look at this. If we have a right triangle, this side is 1, this side is square root of 2 over 2, and this side's length, we're talking about length here, is also square root of 2 over 2. So this would be a 45-degree angle. Okay, so using the Pythagorean theorem then, we have 2, I haven't tried this yet, so we'll see if I can do it right. Squared equals 1 squared, which is 1. Okay, so this, oh, this is beautiful. It does work out. Okay, square root of 2 squared is 2, and 2 squared on the bottom is 4, plus 2, 4, this is this, okay, equals 1. So let's see, okay, 2/4 plus 2/4 equals 4/4 equals 1. It works out. Isn't that great? So this is really just a crazy way of just having these functions we can just automatically plug in and find what these sides are. Or in other words, find out what these coordinates are. Okay? Is that even more confusing? Or does it help? Let me know. All you have to really know is that sine is y, but literally sine is y over r. It's y over the radius. And in the case of a unit circle, the radius is 1. So sine then of pi over 4 is square root of 2 over 2 divided by 1, which is just square root of 2 over 2. Okay, but for later on, it's going to be y divided by radius. So we're going to use all three of these terms, x, y, and r. Cosine of theta, the unknown angle, is x over r. So once you find x, y, and r, you can find all of these really easily. Tangent of theta equals y over x. Cosecant theta is the inverse of sine, so it's r over y. Secant theta is r over x, running out of space. Cotangent theta equals the inverse of tangent, which is x over y. All right, I hope that helped you and did not cloud up your brain even more. Thank you for watching.